Alrighty, 2.6 linear inequalities in two variables. Before we get to this, let's do a little Algebra 1 review, just looking at what slope is, what the solution to an equation is, just a little review. Okay, so the first thing, deciding if an ordered pair is a solution to an equation, all we got to do is plug it into the equation. So if you remember, an ordered pair, that's x, y. Okay, so all you're going to do is replace x with that 5 and y with that 8. And if it is a solution, you will get a true statement. So just going in there, replacing that x with 5, so 2 times 5 minus 3 times 8 equals 34. So and then just simplifying, we get 10 minus 24 equals 34. That's negative 14 equals 34. That is not true. Therefore, no, it is not a solution. Okay, so just plugging that ordered pair in to see if you get a true statement. So and then same thing here. You get 6 times 5 minus 6 times 8 equals 18. We get 30 minus 48. We get negative 18. Well, that is negative 18 when you simplify that side. And negative 18 does not equal 18, therefore it is not a solution again. Okay, so just plugging that value, that ordered pair in to see if it works. Okay, what is the slope of x equals negative 3? Okay, so what's going to help us here is possibly just graphing it. Okay, so x equals negative 3. We're looking for when x is always negative 3. Okay, there x is negative 3. There x is negative 3. There x is negative 3. Okay, I mean, just looking at it, like if we look at that ordered pair, negative 3, 0, negative 3, 1, negative 3, 2, that x coordinate is always negative 3. Okay, and the way I like to think about this, because whenever you get a line and it's x equals or y equals, it's either going to be a vertical or horizontal line. Okay, the way I like to think about it, if it's x equals, we need to cut the x-axis in half. Okay, so we're going through the x-axis at negative 3. So we're trying to find the slope of a vertical line. And if you remember, slope, which we represent with m, is rise over run. Okay, rise up and down. We're going up and down forever. So that's like we got infinity. In our run, we're not going anywhere. So we got a run of 0. And if you go into a calculator and you do anything divided by 0, it's undefined. So in this case, we have an undefined slope. Okay, so there we've graphed a vertical line, and any vertical line, straight vertical, it will have an undefined slope. Okay, so what is the x-intercept and y-intercept of the following equation? So if you remember, an x-intercept is where it crosses the x-axis. Now anytime it crosses the x-axis, your y-coordinate is 0. Okay, so in x-intercept, that y-coordinate will always be 0. For a y-intercept, the x-coordinate is always 0. So we just got to find that missing coordinate for that point. And the way we're going to do that, we know one of the coordinates, so we're going to take that coordinate and plug it in. So for the x-intercept, we know y is 0. So 6 times 0 minus 6x equals 18. We don't know x yet, so we still represent it with x. Okay, so then we get negative 6x is equal to 18. Okay, so then divide both sides by negative 6, and we get x is equal to negative 3. So our x-intercept in this case is negative 3, 0. Now, let's go ahead and do the y-intercept. We'll do that one in blue. Same idea, but now we're plugging in 0 for x. So we end up with 6y minus 6 times 0 equals 18. Okay, 6y equals 18, because that's 6 times 0 is just 0. Divide by 6, we get y is equal to 3. So we get a y-intercept of 0, 3. Okay, now what is the slope of this? Okay, so let's graph it to help us give us a visual of it. We have 2 points, and that's all you need in order to graph a line. Okay, we got that x-intercept of -3, 0. We got that y-intercept of 0, 3. And then we just connect the dots. Okay, now we have the 2 points. Go off of that. Rise over run. Okay, we went up 3, right 3. Okay, so again, slope is equal to rise over run, 3 over 3, or 1. So we have a slope of 1. All right, so that was just a little bit of Algebra 1 review. Those are basic skills that we need to have moving forward, because today we're going to start looking at inequalities of lines. Okay, so linear inequalities, it's just ax plus by. Okay, just that's the standard form for a linear equation, or in this case an inequality, because we're given those inequality signs. Okay, so now solutions to a linear inequality is going to use that same idea. We're going to take that ordered pair that makes inequality true when their values are substituted into the inequality. Now the difference between an inequality and an equation you're going to get one solution. Inequality, you can have multiple solutions. Okay, but for example 1 here, well, 2 examples, you're still plugging those values in, and this, if you get a true statement, it is a solution. Now again, inequalities could have multiple solutions, so we still need to check them every time. So first one, we're plugging in our x and y value. So 4 times 3 minus 2 times 3 is greater than or equal to 8. So just simplifying that left side, 12 minus 6 is greater than or equal to 8. 6 is greater than or equal to 8. That is not true, so this is not a solution. Again, true statements mean they are solutions. Okay, moving over to the next one. 4 times -2 minus 2 times -9 is greater than or equal to 8. Simplifying both sides, we get -8 minus -18. Okay, so that's saying -8 plus 18, which is 10, greater than or equal to 8. That is a true statement, therefore this is a solution. Okay. So again, plug in the ordered pairs, check to see if you get a true or false statement. True statements are solutions, false statements are not solutions. Okay, now graphing linear inequalities, you got kind of 2 options in order to graph these. Okay, you're going to graph them just like you would an equation, but then with inequalities, we have shading to do. Okay, that's the shading is going to be where our true statements do happen, and then we have dotted or solid lines as well. Okay, so you can rewrite it in slope-intercept form and do it just like that. A lot of people will probably go that route. I want to move more towards that idea that we used up here. We found that x and y intercept, and then we just plotted those points, and since it's a line, you can just connect your dots and make a straight line. Moving forward, that's going to be a lot easier if you get that concept down. Okay, then decide if the line is going to be solid or dashed. Okay, so again, for inequalities, we have greater than or less than. In those cases, we are going to have dotted lines. Okay, we don't find the solutions along that line. Okay, but when we have less than or equal to and greater than or equal to, that is when we have solid lines, because we can find solutions or points on that line, and those will work. Okay, then from there we're going to pick a point not on the line, decide where to shade, because again, if we pick something above or below that line, you're going to plug that point in, see if it's true, and if it's true, that's the area you're going to shade. If it's false, you shade the opposite side of that line. Okay, so looking at graphing then, and we're graphing inequalities, y is greater than or equal to 2. Okay, and again, that idea I said, if it's a y equals or x equals, or in this case an inequality, y equals, you cut the y-axis in half. We want that y value to always be 2. So y is going to be horizontal, and we need to go through 2. Now, what I should have done before I did that actually is determine if it is solid or dashed. Since this is a greater than or equal to, it is solid. So I kind of lucked out there. Now, you can always go back if you need to, you know, just eraser and then make it dashed if you needed it to. But in this case, we're good with leaving it as a solid line. Okay, so get the line, determine if it's solid or dashed. Now we need to determine where to shade. Okay, now greater than, just think, what are some values that are greater? Where do you find greater values? For a y, it's above. Okay, so let's pick this point. This is 0, 5, and we're going to take that point, plug it in. Okay, 5 is greater than or equal to 2. So right here is a true statement. Now, with that true statement, excuse the announcement there, but since it's a true statement above, that is where we're going to find the solutions to this inequality. So meaning I could pick any point on here. If I was to pick this point, or this point, or this point, if I plug that into the inequality, I'm going to get a true statement. If I was to pick one of these points down here, we would get a false statement. And if let's just take, even if we just take 0, 0. 0, 0. Okay, so 0 is greater than or equal to 2. That is false. That is not a solution to that inequality. Okay, moving to the next one. X is greater than -1. So it's greater. So we need to make sure we have a dashed line for this inequality. And again, we're going to cut that x-axis in half through. I always kind of put a point on that -1, and that's just a straight vertical line from there. That is dashed. And these horizontal and vertical ones are kind of nice because it's a little easier to predict where we're going to shade. I want it where it's greater. And for the x-axis, the greater values are on the right, so I'm going to pick a point to the right there. This is 1, 0. If I plug 1 into here, 1 is greater than -1. That is true. So I got a true statement here, meaning we're going to shade the right side of that line. Okay, so again, graph your line, determine if you need solid or dashed, and then pick a point, not on the line, so in these cases, completely left or right, or completely up and down, determine where it's true, shade that true area. Okay, now, moving on, we got 2 inequalities in standard form. Okay, again, you can switch it to slope-intercept form, but I want you guys to get in that idea of finding that x and y intercept. Because the way, this is how I do it. Okay, for that x-intercept, again, I know y is 0. For the y-intercept, I know x is 0. So literally, if I plug this y value into here, all that's left is 4x. And then in these cases, to find that as intercepts, you can just keep them as equations. So 4x equals 8, divide by 4, x equals 2. So that x-intercept is 2. For that y-intercept, okay, I know when I plug 0 into x, that 4x, that's going to go away because 4 times 0. So then you're going to be left with 2y is equal to 8. Divide by that 2, y is equal to 4. Now we have the 2 points that we need in order to graph this line. So x-intercept of 2, 0, or y-intercept of 0, 4. And then we said we need a solid or dashed line. In this case, since it's greater than or equal to, we need a solid line because of that. So then let's just make our line. And then from there, pick a point, in this case above or below, to determine what side is true. Now, I always like, when I can, I always like to use 0, 0. That is going to be the easiest point to use, because when I use 0, 0, guess what happens? I plug in 0 there, I plug in 0 there. With our check, so let's say 4 times 0 plus 2 times 0 is greater than or equal to 8. What happens, that left side? It's just 0. Is 0 greater than or equal to 8? No, that is false. So since it is false there, the other side is where my true statements will happen. Okay, so again, finding that x and y intercept. So for the x-intercept, all that's going to be your 2x plus 3 times 0 is less than 6. So all that's left is 2x. And again, when you're finding those x and y intercepts, you can just think of them as equations. X is equal to 3, or that y-intercept. Okay, just doing the opposite, 2 times 0 plus 3y equals 6, 3y equals 6, or y is equal to 2. So now we have our 2 points that we need, 3, 0, 0, 2. Okay, and in this case, since it's just less than, we're going to have a dashed line going through those 2 points. And one thing too, make sure you get those arrows on there. Okay, lines go on forever. And again, this is a case where we can just use 0, 0, doing our check. So then we got 2 times 0 plus 3 times 0 is less than 6. So 0 is less than, not equal to, less than 6. That is a true statement. Therefore, we have a true statement here. So we're going to shade that side of the line. Okay, now looking at some real life examples. Okay, so you have $200 to spend on CDs and music videos. CDs cost $10 each, music videos cost $15 each. Okay, back in my day, music videos just weren't on YouTube. You had to buy them. Okay, same with CDs. I'm sure a lot of you have all kinds of CDs. Okay, now write a linear inequality in 2 variables to represent the number of CDs, X, and the music videos, Y, you can buy. Okay, so X is representing the number of CDs you buy, Y is representing the number of music videos you buy. Now, if we're talking about money, okay, if I buy like 1 CD, that's 10. If I buy 2, 20, 3, 30, okay, the number of CDs you buy, X, you're going to multiply that by 10. So 10X, that's going to represent how much money we spend on CDs. But we are also buying music videos, so we have to add that amount to our total. And again, same idea, but now we're spending 15, so we're going to say 15 times that number of videos that we buy. Now, we have $200 to spend, okay? So if this is representing the amount of money that we're paying for these CDs and music, that has to be less than or equal to 200, because we can't spend any more than that. That's how much money we have. So there is our linear inequality that we have. Now, the reason it's also equal to it, what I should mention, is we have $200, so we can spend exactly $200. Okay, so not just less than, but less than or equal to. So using that idea, now we're going to use that x-intercept and y-intercept idea again. Okay, x-intercept, we know that y-coordinate is 0, so we're going to say 10x plus 15 times 0 less than or equal to 200. 10x less than or equal to 200. Divide both sides by 10. So we get an x-intercept of 20, 0. For that y-intercept now, let's do that one in blue here. We know the x-coordinate is 0. We got to find that y-coordinate. So now we know that y, or the x, is going to go away. So we're going to be left with 15y less than or equal to 200. Divide both sides by 15. Y is less than or equal to, plug that in, 13.3. A lot of real life situations you're not going to get exactly on there. So let's say 13 and a third. That's the same thing as 13.3. Okay, I'm going to erase this stuff real quick, just so we can set a scale on our graph here. Moving slow today. Okay, so let's go ahead and do this graph actually in purple. Okay, so we have to set our scale. We need to get up to 20 on our x-axis. So obviously 0, and I'm thinking let's go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, we're good there. And that should work on the y-axis as well. Okay, now plotting those 2 points, 20, 0, 13 and a third. So in these, you just got to get close. That's somewhere in there. Okay, so we got our 2 points. We're going to make our line now. And since it is less than or equal to, we're going to have a solid line. And in this case, you actually don't need the arrows just because it's a real life situation. We're not going to buy negative amount of CDs or a negative amount of music videos. So we just have to worry about the first quadrant in this case. Okay, now, again, you can use 0, 0 as your check. So then again, 10 times 0 plus 15 times 0 less than or equal to 200. 0 is less than or equal to 200. That is true. So this is a true statement there, meaning we're going to shade here. Okay. So again, yeah, you can buy 0 music videos and 0 CDs, and you still have your $200. That is a scenario that can happen. Or you could buy, let's say if we go here, that's 10 2. You can buy 10 CDs and 2 music videos. If you bought 10 CDs, that's $100. 2 music videos, that's another $30. So $130. You can do that. Okay. As soon as you get above here, so let's just say 24. Okay, 20 CDs, 4 music videos. If you buy 20 CDs, that's $200 itself, and then you bought 4 music videos on top of that. There's another $60, $260. That is not possible with the money that you are given. Okay. All right, last one. Given in a graph, then you're going to write the equation of, the inequality of that line. Okay. So first thing I kind of like to think about is I got a solid line. So in this case, I'm going to need greater than or equal to or less than or equal to. Now, the big thing is we got our slope-intercept one. Right now, I'm not going to worry about the inequality. I'm just going to figure out the equation of it and then determine the inequality that I need. Okay, in order to do that, then, if you remember, M is slope. B is your y-intercept. Okay, so we got pick 2 points. Rise over run. Okay, rise is 1, run is 1. So we got a slope of 1. And since it is going up, if we go from left to right, it is going up, therefore we have a positive slope. So as of right now, I got y is equal to 1x, so I'm just going to write that as x. We have a y-intercept of 0, 2. That b value is 2, so x plus 2 then. So then to get this, we got to write an inequality. So y is greater than or equal to or less than or equal to x plus 2. Let's determine if it's greater than or equal to. Okay, so if we go use that checkpoint of 0, 0, okay, and we know, since it's not shaded over there, we need to get a false statement. Okay, so at this point, just pick a guess if you think it's greater than or equal to or less than or equal to. So I'm going to go with, since it's above, I like the idea of going greater than or equal to. Y, so we're good. Y is greater than or equal to x plus 2. This is just our checking. Okay, and if we plug in 0, 0, 0 is greater than or equal to 0 plus 2. 0 is greater than or equal to 2. That is a false statement. And when we look at the graph, we should get a false statement. So since those two things lined up, That means we have the proper inequality sign. So when we go to write our equation, we need greater than or equal to, and then there's our inequality. Alrighty. That is what we got for today, 2.6. Okay, homework, under your homework folder, graphing inequalities. Got a worksheet there. Work through those. Make sure you're coming to class with questions. Other than that, have a good day.